record. So we actually started afresh. So we went on to bring our Northwind data from source again. And mostly what we did yesterday was more about cleaning each table up and correcting the data types that we have on each one. That was the major thing we did yesterday. Today we'll take it further, and where we need to merge, we'll merge, and where we need to make calculations, we'll do that as well. Okay. And our aim is to be able to relate each table to our fact table. So we find a link between how customers table can link directly into other details. Employees can link directly into other details, and each one of them. Okay. And the only way that can happen is, for example, where customer ID, which is on customers table, we can also have it directly on the other details, you know. So we look for how we can achieve that. Okay. Good for us. Other details and orders are directly linked already. So we can do that match. All of the IDs we have here, the customer ID, the employee ID, any other one, ship via is one of our IDs. We can bring those in. Even the freight, actually, we don't have to bring the freight in. As long as we have a link, we can walk from one table, you know, to the other. But those other IDs we need, and we need them for the sake of, we want to achieve a direct link between customers table and other details, employees table and other details, and the shippers table and the other details as well. Okay, so let's quickly bring those direct ones in. So I'm on other details, and I'm going into home because I need the merge queries, and I'm not merging as new, so I'm just using the merge queries itself. And now I've got other details picked. I'm going to pick my orders table, and I've got a direct order ID link, and we can see it saying that it's found the total rows. Okay, and we need to okay that. Since we found everything, we need to okay that. It brings the whole table in this way, and from this whole table we can select what we want. We have other ID already. We don't have to bring that in, but we need customer ID, employee ID, and the ship via. We need that. Okay, and that's it really. I'm going to uncheck this because I don't want a complicated column name. And yes, we are fine. We can bring those in, and there we have it. You've got those three coming as with the right data types as well. Okay. We also need, we don't have the product ID on here. Oh, we have the product ID on here. So we are fine. But I say that since we have the product ID here, it means other details can be directly linked to the products table. Is there anything on the products table that we might want to bring in? I see supplier ID, category ID. Okay. It will make our work really easy, our data model very efficient if we can bring those two in as well, those two IDs into other details as well. So I click this first as my first table. Under home, I need the merge queries. And this time I'm using the products table. And because there's product ID, I'll pick product ID as well, you know, and it's found all of the number of rows that I should find. And we can okay that. Okay, it's brought the whole table in again, and we'll just pick what we need. We don't need product ID anymore because we have it here, but we definitely need supplier ID, category ID, and that's it for that one. This is unchecked, that's fine. Okay, so we got most of our IDs in. So is there any other ID? We've got employee. I think we've got all of the IDs in, to be honest, because right now, I see order ID. So that can use to directly link to the orders table. Product ID, we can use that for the products table. And we go on to customer ID for customers, employee ID for employees, ship via for the shippers table, supplier ID for the suppliers, and category ID for the categories. So that's looking good. And the reason we are doing this is because we say that there's two types of, we call it schema, which is data structure in data modeling. This is part of us trying to get our data model right. Data model is a kind of relational structure that we build in our relational database. This is relational because there's relationship between each tables in different ways, okay? So the two different type of schemas that we normally get are the star schema, which is the most efficient one. The star schema is where you have your facts table right there, and each of the dimension table is directly linked to it, such that it's easy for you to do analysis from any, any way at all. You could look through these sales here now using the customer ID, first name, last name, or their birth year, because there's a direct link, to the facts table. You might decide to look through the sales type table, the sales ID, or the type name, whatever that means. You can use that for your analysis to look through, okay, maybe total sales or total profit, or number of orders, whatever information you have here. You could use different stores or different cities or region or country or state from here, because it's also directly linked. And you could look through different dates in time, or different product types. So that is always what we aim for. If I'm building a data model within Excel, I haven't done within Excel, to be honest, before, but mostly within Power BI, and it's the same concept. This is what I aim for. Okay, you don't always get that. It depends on how simple or how complicated your data is. But if you've got that mindset from the start, that this is what you want to try and achieve, that would sort of, what's the word I'm looking for? Inform how you go about forming or manipulating your data. Okay, so apart from the star schema, we've got the snowflake as well. Okay, this is I brought this first so we can see that star diagram and why it's called a star schema. Okay, the other one is this. This is still a kind of a star schema. Okay, and we see the definition here. We can screenshot this to just, or I can send the link of it actually, so that we have a read through, different schemas. So this is the star schema, but the idea of the snowflake looks something like this, where you've got your sales table or your facts table. You've got the dimension tables or lookup tables, which are directly linked to it. In this case, we got product that's directly linked to it. The date table or time directly linked to it. The sales rep directly linked to it. Okay, well, we've now got other tables that are linking out of those dimensions. For example, the customer table has a country flaking out, that is being another branch. So this country here, on a normal day, should actually be within this table to make analysis easy. But we see a kind of a branching out where you've got customers being linked to sales and the customer country being linked to the customers. It's also very common with products table where you've got the category. You've got, in this case, we've got product brand, and then from the brand, we've got the category, branching out, okay? So being able to sort of look at, analyze from category level down here becomes a kind of not so easy analysis to do compared to if we had all of this category and brand all consolidated into the products table so that you can have that direct link. So many a time people or the analysts aim for this, data warehouse designers or engineers aim for stuff like this. We don't always get it, but most of the time with your simple data, it should be something that we can get. And that's why we did all of those, merging to achieve that sort of star schema where each one of these dimension tables can have a direct link into the other details. Is that explanation clear enough at all?
Could you explain the difference again? Sorry, I'm so sorry.
Yeah. No, don't be sorry. Okay. So using our own data now, we've got what we call the facts table, which records all the events, and we've got the dimension tables. Okay. So what we aim to achieve is a situation where all of the dimensions that you have a direct relationship. Let me stop using the word link. A direct relationship with your facts table, as we have in this diagram. Okay. In this diagram, here is our facts table, the sales. And each one of our dimension tables, they have a direct relationship with the facts table, such that it's then easy to analyze your data from any angle at all, because they are all sort of feeding directly from where you've got your events happening. Say I want to look into total profits, which I will find within here by product name or brand name or by product category or package type. It becomes so easy because I've got that direct relationship happening. And the same goes for customers. If I wanted to see, okay, how many orders was placed by different customers by their names or maybe by marital status. Okay, we want to see what do married people or single people or whatever it is buy, for analysis purpose. We can still look through because there's a direct relationship, or through their states, we can have that. Okay, so that is the star schema. It is always the most efficient to aim to achieve. But sometimes this is what we get. We get a situation where you've got the customers table and the country is not within the customer's country is not really within the customer's table itself. It's branching out as another table. Such that if you are moving from country to sales now, you've got to move through country to customers to sales. And that's not really the most efficient way to look at maybe total sales by customer country. It would have been best, you would achieve the best result if this was inside here. Or if all of this category and brand was inside here. But in the snowflake schema, we have them as separate tables that are branching out and not directly linked to your facts table. So as we are trying to work through our data, you're already thinking of how would I achieve a star schema with my data? And because you are thinking of that ahead, you are already designing how that is going to be possible. And that is possible, or that is made possible where you see how you have customer key here. There is also customer key within the sales table. That is the direct link that you are going to be able to, that's how you are able to form that direct relationship. Where you have sales rep key here, the sales rep key is also here. So that's where you form the the direct relationship. The same goes for time. There's a key for the time. Key is the same as the ID, by the way. You know, it's like, okay, this is, okay, let's say this is your facts table. They call it key, which is very helpful. To open through the door here, they've got the same key that's forming that relationship that you can use using the time from the time table to the sales table. There's a part where there's the relationship is the same key that opens through. The same goes for products. We have it as product ID, but they have it as product key. It means the same thing. And keys are always very unique. IDs are always very unique. Okay, we wouldn't want to form it on name, especially names of human beings where you've got 2, 3 people, 4 people, 4 different people bearing the same name, both first name and last name. That's not unique enough. But where they each have their own customer ID or employee ID, even if we've got the same 2, 3 employees bearing the same name, but because they have different IDs, it's easier to identify who is falling into what category. That is where the importance of keys or IDs are come to be, you know, within working with data, especially relational data. Is very, I think the long and short of analyzing data comes down to having very unique keys. That is why I must make sure that within my customer ID, I don't have duplicates in the lookup. I mean, I would have duplicates in other details because a customer would appear on different rows because they've placed orders, bought our products at different times. So that's fine. But where you've got the customer table itself, one customer per row, we should not be having duplicates. So if I'm working and I find a situation like that, my job is to report that to IT, you know, so that they can correct that from the back end, you know, so to say. Or if it's within my territory to do that, I must do that. But while I'm doing my work, my analytical work, I must ensure that that is not carried forward in my report, because then that report will be a false report. It won't be right. I hope that explanation helps a little bit more.
You know, that helps. And thanks for that. Then in what will make us, because you said that our aim is to achieve the star schema.
Yeah.
Yeah. So what will make it difficult for us to achieve that and have the snowflake? What will be standing in our way that will not make us achieve the star schema and we'll have the snowflake instead?
Sometimes as you get your database becoming larger and larger in terms of the number of tables that are being designed, that could be a factor. Okay. For example, if we started off having within our product, if we started off having brands, categories, all of that, just within one table when we first started, you know, so I'm having a good time building my star schema, life is good. But at some point, there could be a change within, maybe with the database engineers, and they, for whatever reason, they decide, okay, this is now how we are going to be having it. We don't have all of these products, all of these categories and brands within one table anymore, you know. It's all going to be in different tables. Maybe because, again, we've got too many data within one table, and we want to make that table simpler. Okay, so we are saying, okay, let us make categories table separate. Let us make brands table separate, because we are becoming a larger company, you know, dealing with larger products. So as data grows, there could be the need for the way that the data warehouse is designed to start, doing that. Okay. But having said that, if I know that that possibility is there, I would, from the beginning, make my own life easy and make it as simple as possible by doing all these works that we are doing, bringing some kind of consolidation while I'm doing my own analysis. Okay. Sometimes also it is that you inherited, that's what you inherited from your predecessor. Okay. That's just how they knew how to do it, and if so much work has been put into it already, you don't want to start from the scratch. You might be saddled with having to deal with that. Okay. And there are ways to overcome these things with calculations using DAX as you in Power BI, that is as you start to work with it. But it's just best to have it as star schema. That is always what I've always aimed for. And so far I've gotten with the amount of data that I've worked with so far. So I've not really had that problem, but I know it's because of more complications with the way data was built, from behind the scenes, that it gives a data analyst more work to do. But having said that, maybe that's part of the reason why tools like Power Query was designed, so that as a data analyst, I would know how I consolidate all of those tables into one if it's not going to help my analysis moving forward.
Thank you so much, Mr. David. Thank you.
You're welcome, sir. You're welcome. Okay, so we've brought all of those in, okay? But let's not forget that for our other details, we haven't calculated, because this is a fresh workbook now. We haven't calculated our total sales. Using these three, we haven't calculated our total sales, And to make it neat, there's a way we can do that under add column. I'm going to use the custom column and quickly, so this is going to be named total sales. And I'm just going to quickly write a formula where in bracket, I've got 1 minus this quantity, discount. I'm double clicking discount. Okay. Then times, I'll put that in brackets, and it is total unit price. So unit price, double click that. We can drag as well, or click and insert from here. So unit price times quantity. Times is always the asterisk sign, and times quantity. I'll click on that and use insert instead. So you can either double click or use insert. Okay. So rather than use the long method that we used the other day, where we calculated what's the percentage of this, then take it do the minus. This is a shortcut maths method to check what my final sales will be after the discount has been removed. We don't have to use this, but it's a clean, easy way to achieve it. So I'll okay that, and it adds that on for us, so we can see. Let's quickly double check. Let me bring this. I should be able to drag this closer to the numbers. Okay, so yeah, I just grabbed, pressed down and dragged that to this side. So that way I can look through and be sure that my calculation is right. Okay, so we know already before from, working with this data that 14 times 12 gave us 168. And since there is 0% discount here, it remained, and the same goes for those. For this one, if somebody can quickly please check what is 15.2 times 50, let's see if that 20% reduction is actually giving us the right figure, just to validate what we've done now. And I'm going to change the data type to the decimal number. Okay, let me change it to currency. so that we have 2 decimal.
15 times 2, 15.2 times 50, did you say?
Yes, please.
It's showing 760.
Okay, then if we take 20% of 760 out of 760. So we do 20% of 760.
That's 152. Then you want 760 minus 152.
Correct.
608.
Perfect. So the calculation there was correct. So we've got 608 here. And if time permits, it's worth doing. It's good to check the other ones too, just to be sure. But since that one is right, I'm fine with that. Okay, so now we have our total sales. Is there any other thing at all that we need to add to this table? If not, I'm going to suggest that we close and quickly see what we can do within the next 5 minutes. But so far we've done all our cleaning up, and this is looking good. And if need be that we need to come back and do more work within Power Query, why not? We can always come back and do more work. But so far, I'll go home and then we can close and load. Because I closed and load to yesterday, so that, oh, that's not what I wanted to achieve. That's not what I wanted. I wanted to be able to close and load to data model. Let me see if it still lets me. So let me do that again. Okay, I didn't want to bring this in as the tables that you see here. I wanted to, bring it in as just as a connection, not as bringing all these tables, not at all. Okay, so that we can bring in just the connection of what we've done and load it to the data model. Okay, but let's see if I can still load. So I'm just clicking on one of them, any one, right click. And if we look at the options we have here, to get back into the Power Query, I always click on edit, delete, rename if you want to rename anything there, refresh if you want to refresh for new data sets to come in. But I need this load to. Okay, so I'm going to click on load to, and we see that table is clicked. That's why it brought it in as a table. I didn't want that. I wanted to just create a connection. So only create connection. Okay, and I want this to be loaded to add this to the data model. Okay, so let's see what this brings. Existing worksheet. I was hoping again that it would give us the option to load into a new worksheet, but I'll okay this and see what we get.
No, it gave us the option. It's there. It's beneath, underneath. This worksheet is there.
But it's grayed out.
Oh, it's grayed out.
It's grayed out. I think it's because I already did a table connection before. Now it's bringing only create connection.
Or do we need to refresh before we do that?
No, I don't think so. I can refresh, but I don't think it's refresh. We couldn't complete the action of the pivot table because there's already a pivot. Why is this always saying this grammar, for goodness sake? Well, who did any pivot table now? Oh, I've got, okay, this is what I want. Okay, that looks really familiar. This is exactly what I want. Okay, so sorry about that, because what I opened before, that what we were looking at was our old one, the one that we said we wouldn't be using again, but I opened it because we are going to be needing some business requirement from it. Okay, so that's why I opened it. If not, I would not open it. So total sales by customer name is the first one there. Let's go back to our, so this is the one I want, and I will go back, edit. This is the one that we were looking at just now, I hope. Other details. Yes, total sales. Yeah, this is the one we were looking at just now. And I clicked on close, and yesterday, when it was new, I clicked on close and load to, and I created just the connection. Okay, so it's grayed it out now. But if I didn't do that, I would not have been able to save it. So close and load now. And it didn't bring the table in, okay? It only created a connection for us because I clicked on that connection that you saw earlier, okay? So now I'm right-clicking and I'm choosing the load to option, okay? And we've got only create connection, which is what I chose, and that's why we don't have all the tables. And I want this to be added, add this to the data model. Okay, so let's okay this and see what we get. Okay. There's a problem saving autosave. That's fine. Let me save as with this. Okay. Save. Okay. Just click on it. Or do you want to replace? Yes, replace it. Continue. I don't know why it's playing up now. Okay. I think this Excel is just tired of me. Document not saved. Okay, let me remove that. We do that again. Load to, yeah, data model. And okay. So it's okay, I see. I'm the one not looking. So it's gone on to Power Pivot, which is the data model. You know, the Power Pivot is the data model that we loaded it to, and it's highlighted here. Okay. So if we go to manage, let's see what we've got. Okay. So it's brought in employees, record 1 of 9. Okay. So if we look down here, if we see the first one, employees, I'm just gonna keep going to see the next record. Okay, I should be seeing all of the tables down here, to be honest, not just the employees. So I don't know why I'm saying just the employees. Let's look at data diagram, and it's brought in just the employees. Okay, I'll go back. Let's go back to this one. Is it because I clicked just on the employees? I want all of them. Let me control. Okay, let me bring them in one by one. Load to. Add to data model. They shouldn't really be doing it one by one. Okay. Okay, so let's go back here and see if that was brought in. Okay. So normally it should bring all of them in together, because what happens if I've got if I'm working with so much data, I've got so many tables, why would I be needing to click this one after the other to load it? So there's something not right about that, but just for the purpose of we are here already, let me quickly bring it all in. And just show you how we create the relationship itself. It's also possible to load directly from your data source into this Power Pivot, but it's just good to bring it through Power Query first so that you can clean. Most of the time, you need to clean, and Power Pivot will not let you clean your data or manipulate it in the ways that you need it to be manipulated. Okay, so that's why we passed it through Power Query first before bringing it this way. But if you are very sure that your data is fine, you can always, okay, so we've got all of them here. These are And we've got a connection between these two, okay? So we've got many connections actually between these two, because the two of them in a way are fact tables. But I'm just going to use one link. So you just drag. I'm just dragging from the facts table now down there. And it sees that relationship, okay? So it's calling this the one table, which is a lookup table in this case. Between the two of them, it's calling this the lookup table, while the other details is the many table. Many stands for the facts table. Many because you've got your data, records showing many times. And one for the other one because, and let's adjust the size of this. One for the other one because each row of record is just one. It's just one unique row. And I'm just going to drag from employee here, employee ID onto there. And it forms that as well. Again, that is my one, and employee appears, each employee ID appears here many times, is the reason why it's called one to many. And the relationship is actually called one to many. And that's the relationship we aim for. So product ID to product ID as well. Now, the beauty of Power BI is Power BI, most of the time, if you have ship ID is the same as ship fare. Let me drag it the other way. I don't know if dragging it the opposite way matters, but let's do this. Power BI would have just detected the relationship straight away rather than you doing it manually like this. Okay. Drag this to one side. And the supplier ID is also here. So supplier ID. And that is already being formed. And when I place my cursor on the link, the relationship, we see that highlighted. So you can see if you have dragged the wrong table or the wrong column, and we've got customer ID. You can see if you are joining on the wrong column. Okay. So we see now how this is a star schema. This is a star schema because all of the lookups are directly linked to it. But had it been my products table, we've got categories table somewhere. Did I bring it in yet? Let me go back and get categories table. Okay. I'm just gonna okay that. I don't know what I was saying. Load to, yeah, okay. And we can go back to manage. Okay. It is well. Let me refresh, see if that makes any difference. Refresh. $830 was transferred. Okay. I want the categories table, which I loaded just now, to come in. That was why I refreshed. But I can't see it here just yet.
Could you drag to the side if it's there, the right-hand side? Okay, is it not there? Okay.
It might be. Let's see. Ah, you're right. Thank you. Okay. So had it been our categories table was not directly linked, that is, we've got category ID here as well, we would have needed to link it to product table. Normally it would have a product ID normally. Okay. And that would have formed a kind of a snowflake if that was the case. But the case in our own case now, we've made life easy to be able to directly analyze using the categories or the descriptions as the case may be. So we can drag that in as well. And there, that is how we use Power Pivot in Excel to form relationships, star schema relationship actually, between our relational database. Okay. Then we would aim to start doing analysis, from here, how we can use the Power Pivot chart, it says. Pivot table, how we can do the pivot table from this point and answer our questions, okay? So we've seen different ways to work in Excel. It could be the way we have done it before, where Power Query, yes, load everything in and start using the pivot table to draw your tables and draw your charts out. It could be that, or you may not want to use Power Query for any reason at all, just your normal basic Excel, do your VLOOKUPs and pivot table it and then analyze. That's another way. And pivot, what's it called? This data model one, the Power Pivot, sorry, is another way to achieve that. And it's all good. It depends on just what you want to show and how you want to go about it. And your data, of course, how best it is for you to work with the data set that you have been given. We'll carry on, maybe we should start doing some form of dashboarding from tomorrow, actually, with each question that we answer. And I will say, let us rest from there for today.